describes the preparation for and procedure during heaving up. Anchoring is one of the many important operations coming under the responsibility of deck officers. It involves the use of critical shipboard equipment and requires high level of situational awareness. The key responsibility of the deck officer at an anchor station is to use the anchoring machinery and available manpower for carrying out the operation safely and efficiently in accordance with the master instructions. Proper efficient communication between the bridge and the anchor situation is the most important aspect of anchoring operations. The deck officer in charge should be truly familiarized with the reporting procedures. While anchoring, it is as significant as to give clear commands to crew members as it is to receive the same from master. It is also essential to update the status of the operation to bridge. From time to time, before starting the operation, the officer must be clear on presence of crew members wearing proper personal protective gear equipment (PPE) for assisting the anchor station. Number 2, confirming the anchor use for the operation, port or starboard. Number 3, the anchor lashings and bow stopper are removed prior commencing the operations. Number 4, when using hydraulic windlass, make sure the pumps are started prior operation. 5, check the working of windlass and its controls. 6, if bow thrusters are likely to be used during anchoring, ensure that the required ventilations are open. 7, anchor day in signal ball is ready for hosting after terminating the operation. 8, walkie-talkies radios to be checked. 9, and last, ensure that ship sides are clear of obstructions. Next, explain how to handle cable safely in a non-self-stowing locker. The anchoring system is intended for safely mooring a vessel lying offshore in reasonable weather conditions. The system must be capable of keeping the vessel in position as per the holding power of anchor determined through the calculation of equipment numbers. It is of paramount importance that the system is specified, designed, installed, operated, and maintained in accordance with the manufacturer's instructions, class requirements, and the owner's needs. The anchoring equipment is located on the forecastle, the most exposed place on board. That requires an equipment design that is rugged but also ensures the safe and relatively easy operation. Due to its exposed location, adherence to the equipment's specified maintenance route line is important to ensure its ongoing operational capability. The majority of failure with the anchoring systems can be traced back to the insufficient understanding of its capability and or lack of maintenance. The normal pulling force of the windlass is limited in deep water. It is usually not possible to lift the whole chain length with the anchor hanging free in the water. It should also be noted the existing classification society rules are based on anchoring in sheltered waters. While wind and current forces are considered dynamic forces associated with waves and swell are not, as anchorage are moved further offshore, these forces have increasing influence and they should be taken into account by owners when specifying equipment. Explains how to secure anchors and seal spurling pipes for AC passages. Securing of anchor for sea is done after departure from port for another port. If the anchor is not secured properly, it may cause damage to both the bows, structure, and accessories due to rolling and pitching. Loss of anchor also may take place if the securing is not done as per required procedure. Number 1. Anchor to be well placed inside the hose pipe. Number 2. Bow stoppers are to be well placed to insert the pins. Number 3. Additional wire lashings taken and tightened with battle screw slips. Number 4. Spurling pipes cover placed, secured, and cemented. Number 5. Hoe pipe cover placed and secured. Number 6. Windlass brakes are to be properly tightened. 7. And last, both windlass to be detached from the gear system. Covering, securing, or spurling pipe is one of the most important work when securing anchor for the sea. After departure from port, the water tightness of the spurling, leading to the chain locker from the main deck, upper deck is to be ensured seawater coming on deck during rough weather conditions and heavy rain will enter the chain locker and subsequently to the forepeak store, which may cause flooding in the forepeak area. The responsible officer has to ensure that proper procedure is followed in securing the spurling pipe while the anchor is being secured for sea. Example, placing the spurling pipe cover and securing. Number 2. Making watertight with the cement. Number 3. Putting additional canvas or plastic sheets around the cable to reduce water increase. 4 and last. Check frequently and ensure that securing is in place. List the preparations to be made for berthing alongside. Step 1. The crew should be focused on key issues related to safe entrance, berthing and cargo operations of ship at the port, and subsequently complete the pilot card. Step 2. The passage plan should be updated and approved by the master, who should also be in constant communication with the chief officer and the chief engineering in order to keep them informed well in advance for the time of arrival. Step 3. A meeting attended by senior officers and the officers is crucial in order to discuss and clarify all necessary issues before arrival. During the berthing of the ship, all crew members are assigned duties according to master orders. Therefore, the arrival meeting should also include discussion for mooring plan, so each crew member to be informed for his duties and the requirements and the targets as set by the master for the mooring. The main engine of the ship should always be tested. The testing is generally done before the pilot board on the ship. Additionally, a careful testing of all important machinery system is needed, such as steering gear, generators, important navigation equipment, thrusters, and mooring winches before the maneuvering process starts. Also, anchors maintenance and clean before use should always take place prior arrival. A useful checklist aiming to provide the necessary steps is required to achieve vessel's proper preparation before entering the port. Next, describes the use of head ropes, stern ropes, brace ropes, and springs. Our use of mooring ship alongside a wall or jetty. The two brace ropes are known as the fore and after brace ropes and are used to brace the ship bodily towards the jetty when coming alongside. And when belayed, they limit the ship's distance from the jetty. They can also be used to hold a small ship upright against a jelly within resting on the bottom. The hawsers mark are known respectively as the fore spring and the after spring. Any spring which leads forward is known back spring, and any which leads after it's known as the head spring. When a ship is secured alongside, this prevents it from surging ahead of eastern as its berth, and together they assist the brace ropes to keep it close alongside. They also enable the ship's bow or stern to be swung clear when leaving. By going ahead against a forespring with the helm over, the stern swings outwards while the ship is held from moving ahead by the spring. Similarly, by going astern against a backspring with the helm over, the bow can be swung clear. The head rope and stern rope help the springs in preventing the ship from surging and are also employed to move the ship into its correct berth when going alongside. For a large ship, or one which is berthed a near busy fairway where it is more likely to surge, or for any ship berthed in bad weather, the springs may be duplicated. These are then called the forehead spring, the foreback spring, the after head spring, and the after back spring. Next. Describes the safety measures to be taken when handling mooring ropes wires. Seafarers involved mooring operation should be given additional instruction on the specific equipment and mooring configuration used on the vessel. This should include but may not be limited to examples: the types of winches and windlass and their operations, the location of emergency stop buttons, the types of ropes and or wires used, and the location and use of rollers, dollies, and leads. Crew should make sure that there are enough manpower available to do that task safely. Personnel should never stand in the blight of a rope or near rope under tension, and they should treat ropes on the drums and bollards with the utmost care. Detailed familiarization should be take place to all new joining ship regarding the installation, use, and hazards related and permanent loose mooring equipment. Based on the risk assessment, appropriate countermeasures should be put in place. Next, describes how to join two mooring ropes together. The quickest way to connect two ropes is to tie them together. The most secure way to connect two ropes is to splice them together. When you need to connect two lines, you will have to weigh out the pros and cons of each options to decide what is the best for you at that moment. If you have plenty of time and the skill needed, splices will offer the best connection if you are in a rush. A simple knot might meet your immediate needs. Splices offer a secure, permanent connection which result in no loss of strength. This is because a properly executed splice will evenly distribute the forces across all of the fibers in the line without creating pressure spots of increased loads and tension. The disadvantage of splicing is they can be time consuming and require skill set for each type of line. The lines are characterized as three-strand, single braid, double braid within the single double braid. They are then broken down into class 1 and class 2 fibers. Each type of upline three-strand, class 1 and class 2, has its own rules about splicing. As you can see, it can get complicated hurry. The next option is to simplify tie the lines together by way of a knot. Knots create areas of increased stress which weaken the line. The bowline is known as the knot that retains the most strength in the line, retaining approximately 80% of the line strength. Other knots will be more detrimental to the line's total strength. Describes typical mooring arrangements. Mooring is a procedure to anchor the ship to a fixed or floating element and keep it connected during loading or unloading operations. Safe mooring must withstand several forces, such as wind, the current, the tide, and waves. We are going to review the most common kinds of mooring, what they consist of, when it is advisable to use each of them. Ship-to-ship transfer. Ship-to-ship transfer means mooring two ships in parallel to transfer cargo. During this operation, one of the ships may be anchored, or both of them in movement. The procedure consists of an anchored or slap ship being approached by another at the most reduced angle possible. During the approach, the maneuvering ship comes close, seeking a parallel course, reducing the distance until the fenders are in contact. Next, single point or single buoy mooring. The mooring method consists of floating dock or buoy outside the port to handle liquid or gaseous cargo from ships like oil vessels. It is used in ports that do not have specific facilities for this sort of large ship. The ship is tied to a buoy with the aid of one or two chains which are secured on board at the end of the prow. This mooring operation requires favorable weather with low waves and wind. Next, conventional or multi-buoy mooring. With this mooring method, the ship's prow is secured with its two anchors, while the poop is secured to a buoy. The berthing position is approached at a 90-degree angle. The starboard anchor is released at a determined location as the ship moves forward. When the ship stops, the port side anchor is released, thereby positioning the poop along the central line, bifurcating the buoys. Next, Baltic mooring. When there is a strong wind and port and boat must be moored without tugboats to a dock knot, resistant to impact. Baltic mooring is used. The captain or the pilot use ship's anchor and onboard cables to reduce this impact, mooring the ship such that it is berthed lengthwise to the dock. Next, Mediterranean mooring. This is consists of mooring the boat in perpendicular to the dock, with the poop surface parallel the jetty. This procedure is used when there is insufficient dock space to moor the boat. It is also used when there is a ramp on the poop connecting to the hold. Next, anchor mooring. Lastly, ships sometimes use the anchor along with the mooring lines to drag the vessel outside the jetty while anchoring or de-anchoring, thus helping to control the speed of lateral movement toward the dock. Of note in this modality are running mooring, which provides greater control over the ship, and standard mooring used during crosswinds and which takes longer. Next topic. Demonstrates how to put a stopper on a rope or wire rope. First, secure one end of the stopper as near the bits as possible. This is done by ribbing one end of the stopper through the eye at the other end and slipping the bight, thus form over the bits. Number 2. Now, lay the stopper over the mooring hawser or wire and watch carefully whether the stopper lies with the lay or against the lay. So, if the stopper with the lay, remove it and take it under the mooring hawser. This will now be against the lay. 3. It will be found that if the stopper is made fast to the right of the hawser, when looking along the outward going part of the hawser, the stopper nuts has to be started from top. Conversely, if the stopper is made fast to the left of the rope, the knot has to be started from below. Number 4. Take a half hitch. And last, take another riding turn as for rolling hitch. Back of the stopper rope as shown in the figure and take a number of turns around the mooring rope with the lay. Now catch the end of stopper and pull it away from the bits at an angle of about 30 degrees with a mooring hawser. Sometimes the riding turn is omitted if the strain is not too much. Next topic. Demonstrates how to make mooring rope or wire fast to bits. One of the most important things to learn about when installing mooring lines, other than proper anchor selection installation, is knots. They can be a bit daunting for the uninitiated, but give them some practice and over time you will find they are quite easy and very useful in everyday life. There are 5 knots used for setting up mooring lines, and they are generally part of class of knots called dynamic knots, meaning that they adjust or flex with the rope and do not reduce the rope's integrity. The opposite of a dynamic knot is known as the static knot. This knot tend to only tighten with the rope and never release the tension they store. You will be familiar with these knots already as they are the one that you can never get undone once they are tied. The most common static knot is the overhand knot, which is the also most simple knot. When an overhand knot is tied into a rope, it creates a pinch point and does not allow energy to be absorbed along the length of the rope. Thus, when the rope breaks, it will generally do so right at this knot. For the reason, We never use the overhand nut or other static nuts when constructing or repairing mooring lines. Next topic. Describe the use of self-tensioning winches. Winches designed to have an automatically whenever the line tension falls below a certain preset value. Likewise, they pay out if the line tension exceeds a preset value. The use of the self-tension winches is not recommended except for mooring deployed at 90 degrees to the ship axis. This invention relates to mechanism for maintaining automatically a predetermined tension in a line that is wound on a winch drum to handle loads and more particularly adapted for a use upon a tilting platform, such as deck of ship, to hoist to said platform loads that are rising and falling due to a wave action. Another application is for mooring winches where the lines from to ship to a dock have to be adjusted due to change in tide or ship's loading. Among the objects of this invention are to provide means that will automatically take up slack in a line having one end connected to load and other wound on a winch, or pay out the line when the tension there increases above a fixed maximum value. To provide means for preventing the operation of the automatic mechanism when the load must be sustained by the line. To provide a bypass mechanism that will permit automatic control of tension as above. Mention well the output of variable delivery hydraulic pump used to operate the winch continues in the same direction. Importance of keeping mooring lines clear of the propeller and notifying the bridge when the propeller is not clear. Mooring operation is one of the important tasks that seafarers have to perform on ship's decks. Technically, the operation may seem simple, but there are several dangers associated it with. As a seafarer, you must have heard about death traps on ships and how crew members have lost lives during mooring operation. Number 1. Don't allow any extra crew member on the deck. Ensure that no extra personnel in present mooring station except those who are involved in the operation. Anyone who is not assisting in the mooring operation must be asked to leave the mooring station for his, her, and others safely. Number 2. Consider weather condition. Before planning the mooring operation, consider the weather condition by taking factors such as wind and current. The shipmaster and responsible officer must have the details of current and the future weather data before commencing the mooring operation. Next. Have knowledge of snapback zone and rope bight. All personnel have involved with the mooring operation should be aware of the snapback zones and the rope bight. Next. Check all the mooring equipment. Check all the equipment, mooring winch, drums, windlass, etc. involved in the mooring operation for any kind of problem. Proper routine maintenance is the key to ensure the smooth running of mooring equipment and system. Don't forget to check the load sensors of mooring winches. Next. Check the tail of mooring line. If the mooring wire is provided with tails, short lengths of synthetic fiber rope which are placed on series with the vessel's winch mounted wires to decrease mooring line stiffness and thus to reduce peak line loads and peak fatigue due to vessel motions. Ensure same size and material of tails are used of lines in the same service, breeze, spring, and headlines. Different tail size and material would lead to uneven load in the mooring line. Next. Tend one line at a time. Only one line should be tended at a time during a mooring operation. If it is not done, it may increase the load the other extended lines. If two lines are extended together, it may lead to overloading and breakage. Follow the orders of the master or responsible ship officers properly to avoid any kind of mishap. Next. Keep a check on the mooring line load. Ensure that allowed breakable load in any mooring lines does not increase 55% of its maximum breaking load. This is to prevent the line from breaking. Next. Avoid mixed mooring. Mixed mooring is extremely dangerous. Generally, mooring lines of the same size and material should be used for all leads. If it is not possible due to the available equipment, all lines in the same service, breeze lines, spring lines, head lines, and stern lines should be of the same size and material. The use of mixed mooring comprising pull links in synthetic ropes used in conjunction with wire should be avoided. If synthetic rope and wire are used in the same service, the wire will carry almost the entire load while the synthetic rope carries practically none. Next, keep a continuous check. Load on mooring lines must be checked continuously even after mooring operation is over. If there is any change of the ship ballast condition, the lines must be slacked or tightened accordingly. The condition of the rope material should also be checked to foresee unfortunate accidents. And last, arrange mooring lines symmetrical. All mooring line must be arranged as symmetrical as possible with the brace line. The brace line should be the perpendicular to the longitudinal center line of the ship, and the spring line should be parallel to the longitudinal center line. Describe how to make pass tags on towing hawsers or lash up alongside. Conventional tags. These tags are used worldwide and their characteristics vary. These tags can be equipped with fixed propellers, single or twin screw, left or right-handed, and single rudders with fixed nozzles. New buildings may have steering or nozzles, controllable pitch propellers, and nose rudders. Tags may be fitted with tunnel or retractable azimuth thrusters. Workboats would usually fit into this category of craft, and their general characteristics are maneuverable and effective for most work, but less maneuverable than azimuth stern drive and tags or tractor tags. Next, good steering ability, especially as a forward pulling tag. Next, good sea keeping ability, good ballard pull toward output. Towing point is usually situated just after or amidships. Astern ballard pull reduced by up to 50% of forward ballard pull. Increased risk of girding when towing. Next topic. Describe the use of fenders during berthing and when secured in position. One of the primary factors external to the ship's mechanical or electrical system that come into effect while berthing vessel is the marine fender system. An efficient fender system saves the ship from external damage that would have otherwise occurred to the hull plates or to the berth of jetty, which comes in contact with the steel plates of the ship. Theoretically speaking, a ship is to be brought at a negligible speed to the berth. A small increase in speed will give rise to an exponential jump into the momentum, which essentially is the product of mass and velocity. For example, the displacement tonnage of 10,000 when multiplied by speed of 1 knot has half the momentum when multiplied by speed of 2 knots. The energy of impact is twice, thrice, 4 times, and so on with every knot or of increase of speed. Now, when it comes to practice the speed, always cannot be restricted to bare minimum. Towing or to certain conditions such as tides, wind effects, tugs, erratic coal, engine failures, etc. A good marine fender system can save the day in such exigencies. Ideally, a marine fender system should be cost-effective with low maintenance costs and high durability. The material should be locally available should a case of replacement arise. In the last topic, describe methods of mooring to a buoy. Ship-to-ship transfer. A ship-to-ship transfer operation is the transfer of cargo between seagoing ships positioned alongside each other, either while stationary or underway. Cargoes typically transferred by STS methods include crude oil, liquefied gas, LPG or LNG, bulk cargo, and petroleum products. Single point or single buoy mooring. A single buoy mooring or SRM, also known as single point of mooring or SPM, is a loading buoy anchored offshore that serve as a mooring point and interconnect for tankers loading or offloading gas or liquid products. These moorings usually supply to dedicated tanker which can moor without assistance. Next, conventional or multi-buoying mooring. Conventional buoy or multi-buoy mooring is the ideal mooring system where there are limited quay facilities, infrequent loading, offloading operations, and as an alternative to a single point mooring, it compromises multiple buoys to moor the tanker securely and prevent weather banning. Next, Baltic mooring. Baltic mooring is a combination mooring of a vessel alongside the berth which employs a stern mooring shackle to the offshore anchor cable in the region of the Gangerling. Baltic mooring is a safe option to berth a ship on a windy day. Next, Mediterranean mooring, also known as red mooring or med mooring, is a technique for mooring a vessel to pier at a perpendicular angle. The ship tags occupies less spaces as it's connected to a fixed length of pier along with the wind rather than its length. The disadvantage of Mediterranean mooring is that it is more likely to result in collision and that is not practical in deep water or in regions with large tides. And last, anchor mooring. An anchor mooring fixes a vessel position relative to a point on the bottom of waterway without connecting the vessel to a shore. As a verb, mooring refers to the act of attaching a vessel to a mooring. The term likely stems from Dutch verb meren, to moor, used in English since the end of the 15th century.